Enrolment over Secure Transport, or EST, is a protocol for X509 certificate lifecycle management for network devices. In this demo, I will configure and deploy the Dogtag PKI EST service and use the Cisco libest example client program to request a certificate. We begin with a deployment of Dogtag PKI having only the CA subsystem, which we can see by executing PKI server subsystem find. So only the CA subsystem. Now we will create a group and a user account for EST registration authority credentials, which the EST service will use to authenticate to the CA subsystem for issuing certificates. So we use the PKI command line client program, provide the NSS database credentials, and run the CA group add command. And we'll call the group EST RA agents. We'll add the user account. We'll call EST-RA-1. And we'll set a password. We can also enable client certificate authentication, but to keep this demo simple, we'll use username and password. Now we add the user to the group with the CA group member add command. And now the credential is prepared. Next, we need to create a certificate profile suitable for use with EST. I have already prepared a profile configuration. The profile name is EST Service Cert. We use the session authentication instance to authenticate the EST RA account and have an authorization rule saying that only members of the EST RA agents group can use this profile to issue certificates. The rest of the configuration is fairly standard. The authority information access and CRL distribution point extensions would need to be set to values appropriate for your environment. The common name of the issued certificate will be copied from the certificate signing request, or CSR. And we also use the common name to SAN default component to copy the common name attribute value to a DNS name value in the subject alternative name extension if it looks like a DNS name. So let's create this profile. And we need to enable the profile. And we're ready to deploy and configure the subsystem. So we become root. Move to the configuration directory for the Dogtag instance. We see there's only the CA subsystem but no EST subsystem yet. Now we run PKI server EST create. We have our EST configuration directory. Nothing in here yet, but we need to write a backend.conf to configure the backend. The class will be the Dogtag RA backend. The URL is the URL to the Dogtag instance on this machine. You could configure it to talk to a CA subsystem on a separate machine. The port is 8443. We tell it to use the EST service cert profile, and we give our username and password. Now we run PKI server EST deploy, and the EST service will be deployed. On another machine, we'll use curl, first of all, to retrieve the CA signing certificate so that we can trust the HTTP certificate for the Dogtag instance. And we can actually use the EST protocol to do that. We'll do it directly via curl. We need -k, which says not to verify the client certificate. In real-world deployments, you would have your devices bootstrapped with the signing certificates for the HTTPS certificate for the EST service or the trusted routes. So we're talking to f36.2.ipa.test port 8443, and then the .wellknown/est/ca certs resource, which is defined in the RFC for EST. So we get a bunch of base 64 output. This is actually base 64 encoded DER representing a PKCS7 object. So we'll base 64 decode that and send that output to OpenSSL PKCS7 print certs, and we'll write that to cscert.pem. We need to set inform DER. It was expecting PEM, but it's getting DER. And there's our server certificate. Sorry, the CA certificate that signs the server certificate. Okay, now we can use the Cisco libest client to retrieve a device certificate over EST. First, we'll set the environment variable EST OpenSSL CA cert to point to the trusted CA certificate, which we just retrieved. And now we'll run the EST client program. We give the arguments -s to give the server name, -p for port, -o for output directory. Actually, we'll need to create this first. We'll ask for the key and certificate to be output as M files. -e is the command to request an enrollment, and we'll give the common name for the CSR to be generated as this machine's host name. And before we do all that, we need to make the EST directory. Okay, so the command was successful. This output is just saying that it didn't find a private key already in the EST directory, so it generated one for us. If we have a look in that directory, we see a key file and a certificate file, and we can use the OpenSSL X509 command to pretty print the certificate. There we see the issuer is the same CA as issued the HTTPS certificate. Validity period of 3 months. The common name is f36.0.ipa.test, this machine's host name. And as we expected, we also have a subject alternative name extension containing the host name for this machine as well.